the most forward-looking session of India Space Congress 2025. In a world which is racing towards digital equity, connectivity is not a luxury, it is an infrastructure. And as we leap from 5G to 6G, from terrestrial towers to orbital networks, the question before us is clear. Can space-based communication seamlessly integrate with next-generation telecom? That's the most important question we need to delve deeper into. And this session, SATCOM and 5G, 6G integration, enabling telecom-satellite partnerships, dives straight into that future. We will explore how satellites are shaping 5G backhaul and how it enables enterprises, great solutions, and contribute to global digital inclusion. Inclusivity is one of the most important aspects in all the topics that we discuss these days. And India's policy landscape is evolving, and PM Vani, BharatNet, and Gati Shakti converge with space ambitions. This discussion will also touch on the much needed regulatory clarity, investment pathways, and international alignment required to build a robust SATCOM 5G, 6G ecosystem. Leading this cutting-edge conversation is our moderator, a sharp mind at the intersection of strategy, innovation, and space entrepreneurship, Ms. Grace Khanuja. I hope I pronounced your name correctly. Yeah. Please welcome her on the stage. She is a management and a strategy consultant at Novaspace. Thank you, Ms. Grace. Joining her, we have distinguished leaders from telecom technology and satellite solution, Mr. Vikram Tiwathia, Deputy Director General, Cellular Operators Association of India, one of the most respected voices in India's telecom policy and a spectrum landscape. Welcome, sir. Next, we have Mr. Manoj Gurnani, Chief Technology Officer and Head of Strategy at Nokia India, a veteran of telecom infrastructure and 5G innovation. Joining them, we have Mr. Vishal Mathur, founder of Vishal Mathur Consultants, LLP, with deep insights into device ecosystem and digital acceleration. We also have Mr. Vinod, Kaul, Regional Vice President, South and Southeast Asia, Gilat Satellite Networks, bringing a global perspective on satellite connectivity solutions. With that, I now hand over the session to our esteemed moderator, Ms. Grace Khanuja. The future of connectivity is calling, and this panel is ready to answer. Thank you.
Thank you so much for the introduction, and it's a pleasure to... Hi, everyone. Yeah? Okay, thank you so much for joining us today. It's a great pleasure to be moderating this session, and as she rightly said, that India is at a crossroad where 5G and 6G is becoming an essential priority for the nation, and satellite connectivity is becoming so accessible. So it's essential for us to understand how the integration between the two develops, and that's what we're going to unpack today. I will start off with welcoming our esteemed panelists here. Thank you so much for joining us. We have a mix of different perspectives here, and I'm looking forward to having the discussion. Overall, I would like to keep it conversational and dynamic, so feel free to build upon each other's pointers, and I will keep probably 10 minutes in the end for the audience to ask questions as well. Okay, before we deep dive, I would just want to get like an overall picture of how you think about the topic, and to set the scene, this is a question for all of you. What do you see as the key enablers and challengers for the telco-satellite integration, particularly in India, where rural broadband and 5G, 6G readiness are national priorities. So probably Vikram, do you want to kick us off?
Thank you very much, Grace. So, basically, it is for countries to see, okay, what kind of services you want to offer to which, to the citizens, to which a service has to be delivered. Now, the good news is that broadband connectivity, and mostly consumed on a form factor of the mobile device, right? So globally, I think the mobile connectivity or terrestrial connectivity has done a pretty substantial job. And, ability to deliver services, it's not just calling, but, banking, just your daily needs, which people use. So that has been a pretty good story. Now we are reaching a point where the terrestrial network has not reached for various reasons, which are predominantly economic, right? If it makes a business sense, then obviously somebody would have gone there. So there are vast geographies globally, including India. I mean, even the US, the BEAD program, right? Because the distances are very huge, and it doesn't make economic sense to put a, ground-based network coverage. So that is a role where the satellites obviously come in. It's nice to see people from the Indian Navy, Air Force, Army, because these are the people who very often operate in areas, where you do not have the local population or in far-flung areas. So satellite connectivity and integration with terrestrial networks has seen a lot of attention in the World Radio Conference in Dubai in 23. And out of the various agenda items for the World Radio Conference scheduled for 2027, I would say maybe about 80% of the agenda items are satellite oriented, whether it's for spectrum or for other standards. The other good news is, in terms of integration, is that the 3GPP, which is the standards making body, has also baked it into as part of their work schedule, the integration, NTN integration. So work is on, and I'm sure we will dwell on this as we go along. Back to you, Grace. Thanks.
Thank you. Vinod.
Thank you, Visai, and my co-panelists for an interesting session. And we'll have a 1 hour interesting time debating on the topic. To kick off, Grace, the point is that what are the enablers and what are the challenges in integrating the 5G and the satellite space? If you see, as of today, both 5G networks, we have started with 2G, 3G, 4G, we're moving to 5G and 6G. And satellite networks have coexisted, and we have been working with this 5G technology, 4G technology, 3G technology in terms of cellular backhaul, providing via satellite, which are mainly geocentric satellites and now we see new orbits of MEO and LEO coming into picture. So one of the key challenges which we see, if we have to integrate as we move from to 5G and provide a ubiquitous connectivity, is that we do have to move to standards. As Mr. Tiwathia said, that standards is something which will broaden the scope of 5G ubiquitous connectivity, and which will have its own challenges, which we will discuss the challenges on that. But one of the key challenges would be that. And second thing is where we see the enabling this kind of connectivity would be on the technology front, where we you should have networks which are multi-orbit networks, because we have now GEO, we have MEO, and we have LEO space available. So the networks which should be used should have multi-orbit capabilities, and primarily, if I see the government policies in terms of in terms of enabling in countries this kind of integration would be how to manage the spectrum between a 5G and a satellite spectrum, where there are overlaps and where there are challenges. That should be kind of been rectified in a better manner. And lastly, we do have a challenge on the satellite in terms of, somebody was talking yesterday that when you land and come to India, that the satellite phone is not cannot be used in India. So it's a big challenge when 5G is talking that we should have a normal handset satellite enabled, and we don't have a policy how to use a satellite phone in India. So that's something which one has to look at from the policy side.
Perfect. Hold that thought, because that's my next question. But Manoj, do you want to introduce the topic from your end?
Hello, can you hear me? Yeah, namaste and hello everyone. I think hitherto satellite systems were, and the telecom systems, they were both different worlds. I mean, if you talk about satellites, they had their own terminals, they had their own standards, own technology. It was largely GEO before LEO really arrived. They had their own waveforms, so everything was so different. And even within the satellite world, if Iridium would work on one technology, the other competitor would be working on some other technology. So it was a very, very closed system, as one would say. But now we have to realize that telecom is critical infrastructure, and therefore both the worlds, telecom world and the satellite world, they will have to co-work. And there are three distinct areas in which they can actually work. The first is the ubiquity. And I'll add to Vikram's point, in terms of the population coverage, high percentage of the world is covered, 90–95%. But if you talk about in terms of the wireless coverage, in terms of the Earth's surface area, it would be 80% is still uncovered. That's because of the hinterland, oceans, water bodies, etc. And so the first thing is the ubiquity, which means the 80–90% of the area where the terrestrial coverage is not there, do you have a backup, right? So I think that's where satellite comes into play. So that's where they kind of co-work. The second thing is what we call it as service reliability. And when you talk about service reliability, it means the satellite actually acting as a backup to the terrestrial network. And that's really needed because of the fact that telecom networks are critical infrastructure today, right? So can you actually have a HAPS layer where should there be a calamity or should there be a disaster, can you actually have a backup to the terrestrial network? Yes, satellite can do that. So that's the second aspect, the reliability. The third aspect really is the scalability, in which you can actually, during the busy hours, have the satellite, acting like a offload kind of a layer. So to sum up, I think these are the three areas: ubiquity, reliability, and the scalability, where both the worlds can really coexist.
Okay. Perfect, thank you. And Vishal?
Good morning, everyone, and hello to my fellow panelist and moderator. My name is Vishal Mathur. I've been in the satellite industry for the last 27 years, been fortunate to be a part of launching a sports broadcasting ESPN to selling transponder space to KU, K-band, and to C-band, and now representing Astranis Space Technologies, a US-based micro-geo communication satellite manufacturer. So coming back to the question, I think India is on a cusp of a digital revolution, and with the recent announcements and recent initiatives, BharatNet, PM Vani as introduced by the fellow panelist, 5G and 6G revolution, I think satellite is going to be the key enabler to support these initiatives. I think that primarily because of the new space reforms, we see B2B partnerships coming into the play. Yesterday we heard and we saw the multi-orbit panel whereby Geo SES M3O power was there. Then O3B and Airtel partnerships are there. So as a key enabler, we do see reforms opening up in India. And then on the other side, we also have, so we manufacture, build and operate dedicated K-band satellites, which is used for communication purposes, meant for enterprise, governments, and telcos. So we complement and we integrate telcos' efforts on the ground, right? It's a dedicated K-band satellite, what we produce and manufacture. And on top of that, we also have a sovereignty issue, right? We spoke about multi-orbits yesterday, but I believe geostationary is still going to coexist, and there's going to be a huge demand on geostationary moving forward because of the sovereignty issue, right? So also we have our current architecture in India also supports a satellite which can easily blend with the telco infrastructure, right? So overall, it's going to be a blend of satellite technology, and one of my panelists rightly said, especially the fiber is so good in the urban areas, but in the rural areas, is satellite which is going to complement the telco's efforts.
Yep, okay, thank you. So from what I gather, there are two aspects that I really want to discuss at this point. One, it would be a policy standpoint, and then the next would be the technical side. So from a policy standpoint, what are the most urgent interventions that you, in your opinion, are needed to truly accelerate this integration? So Vikram, do you want to kick off?
Thanks, Grace. So, policy-wise, the important part, I think, a very major part would be security. You see, the current satellite networks are, global in nature. Satellite service by itself is predominantly global in nature, and I'm talking of the service which is to deliver into this form factor, right? And given the geopolitical, environment, which is not really very new. It's always been there. But governments would want to be able to, have a plug-in for, legal enforcement. So the LEA part or the LI part will be an important policy aspect which needs to be, handled. The other important part is who's going to put the money. In terms of policy, what policy measures do governments take to incentivize somebody to invest to provide that service? Right? So currently it's predominantly the investments that you see on the four larger constellations is private, two being from the US, right? And one is Dutch, and one, of course, the investment by Mr. Mathur. Right? But in the overall sense of things is that how do governments, in policy terms, facilitate investment? Because if it is the government's onus to provide service in an uncovered area, there has to be some government money itself or incentive. And what kind of funding, whether, from what source. But in policy terms, there has to be incentivization for investment in building up the network. Right? The third policy, as somebody mentioned, is that you can't own a sat phone in India yet, right? So that relates to the security part. But yes, again, the devices and affordability or the cost of the device, how in policy terms do you address that? So I'll leave it at for policy on these three aspects. Thank you.
So since we are speaking about the industry and the handsets, so Manoj, would you have a view on the topic from a Nokia sense?
Nokia is not in terminals now. We are a network
I know.
company.
But in general, from an industry investment perspective.
Yes. I think terminal will play a huge part. It's an important part of the network. And it has to be affordable. If you talk about the roadmap, release 17 onwards, I think you will have a massive user penetration which will support the NTN chips. So it's going to get better, more affordable. And for a country like India, for the mass adoption, I think it has to be at a price points where it is, extremely attractive. So be it D2, direct to device, or be it the normal NTN, the cost of the CPEs or cost of the fixed terminals or cost of the mobile terminals, it has to be affordable. So, and I think it's a function of ecosystem, be it chip companies, be it the supply chain decisions which the government takes, so on and so forth. But eventually, for it to be successful in a country like India, the device cost will play a major factor.
In India, we have an ecosystem of service providers. We have telecom service providers, and we have also VSAT service providers. We who offer typically VSAT services on regular geo satellites, which they have been doing from last 30 years. I think one of the, while we're talking of 5G integration and moving forward, one of the key things would be to enable these VSAT service providers to offer, to be at level playing field with telcos, to offer VSAT services purely to fill in the gaps in the Bharat broadband plan or in the PM Wi-Fi Yojana. So that's something which on the policy side, which the government should look at, and besides the integration of the 5G as we move forward, but we have something which is working today. And while the integration of 5G to the NTN will take its own pace, and we'll just debate more, but we have something called VSAT service providers right now who are offering services in India, and who can fill in the gap to provide broadband or to provide Wi-Fi backhaul on regular satellites, which is GEO, and even today we have MEO satellites available. So that is something that the government should look at and do some changes where the VSAT service providers are at par with the telcos to offer such services.
Okay, and on the technology side, what do you think is holding us back in achieving like a seamless integration, or what are the next steps in achieving a seamless integration?
I think on a 5G, if you ask me, Gilat, I represent Gilat. I am based in India, handling the Asia market. Gilat has been pioneer in integrating SATCOM networks with telcos. We have tens of telcos globally with thousands of terminals doing cellular backhaul. We started with 2G, doing backhauling for remote areas. We then moved to 3G, we moved to 4G, and we are today working with some of the 5G networks also. So as such, the technology today is available, which is based on DBBS2X, which as the panelist said, it's an island of technology. My terminal will work on only my network, but it is working today. So there is an integration which is happening. There are technologies available now. All these satellite operators and some of the telcos are heavily invested in these technologies on the baseband side, on the DBBS2X networks. Now, there has to be a roadmap. It cannot happen that suddenly all of this investment moves to a 5G NTN tomorrow. So what we see industry changing from DBBS2X, which is today, seamlessly to a next level where we see that R17 is something which is going to come, and we will see it's a kind of a narrow band service which will happen, and then we'll have R18 and R19, which are broadband and enhanced broadband services on the NTN. So the first step is virtualization of the current networks on the SATCOM side. So what many of the OEMs on the SATCOM side and along with the operators are working on virtualizing the platforms, providing it on the cloud, so that they can work in the new setup of cloud. And then next step would be moving these waveforms to a 5G hybrid 5G NTN kind of a thing, where the terminals remain still what they are in the market, DVB-S2X, but on the gateway side, you have a virtualized platform connecting to a 5G core, and then the next step would be the virtualized platform getting on a 5G RAN. The 5G RAN can be a node B on a satellite, which can be a regenerative payload or a native payload. And then the 5G RAN would be then, you will have as Manoj said, that you have chipsets coming on R17. So you'll have terminals, you have handsets which would be capable of connecting directly to a 5G RAN. So you will have those in the market. So a satellite operator or a telco will have an infra which has multi-waveform kind of a network, where there will be some technologies, some terminals working on S2X. As we move forward, some of them would be working on the R17 5G NTN terminals, which could be a handset, which could be a device. And that's how the whole integration will move, and I see it happening in the next 3 to 5 years. That's what we will look forward on the technology front.
Just wanted to add on what Vinod has just said. Technology from the satellite perspective to support the telcos. Astranis, is a dedicated satellite where we do a lot of beam reconfiguration, beam slicing. So for example, there is a capacity requirement over Andaman and Nicobar Island, just as a hypothetical situation. We can reconfigure and do beam slicing, which can cover that particular region. And if suppose the telco says that tomorrow my demand is over, let's say, on the southern part of India, so we could reconfigure the beam towards the southern part of the India. So, as the ground progresses, the telcos are progressing on the ground. At the satellite side, from the bus perspective also, there are a lot of technological advancement which is happening. So, and of course, as I said, that sovereignty is the key for us, because being a geostationary operator, we support all kinds of applications, whether it's defense, whether it's consumer broadband, whether it's telcos. So, yeah.
Yep. Interestingly, you brought up applications. So I know, Manoj, you spoke about D2D. So I just want to understand, from whenever we think of NTN, direct to device does come to mind, and it's a new hot topic right now. So I just want to understand your perspective as to how realistic it is in the Indian context, both today and in the next 5 years.
I think for any technology to be successful, a very important aspect is the ecosystem. Let me go back to the 3G days. The mistake which we made in 3G was that we actually ended up in 3 technologies. We were talking about WCDMA, China had its TDS, CDMA, and then CDMA world had its CDMA 2000 world. And they couldn't kind of converge. 4G was successful because we had one unified standard, which was LTE, right? And I think we have to learn the lesson from that experience. D2D, I think, is a technical reality. We all know that. But the thing is that which direction which we should be taking. Should it be 3GPP, or should we be trying to rediscover altogether a different world? Different world of chips, different world of ecosystem. I am the strong advocate of the fact that we should actually move into the 3GPP world, for the simple fact that, this is where all the global minds have put their minds together and come up with the unified, harmonized standards and technologies. We should not be discovering altogether a new ecosystem.
And overall, from a commercial perspective, do you think D2D takes away the stage from cellular backhaul or rural broadband when we talk about satellite and telco integration?
See, it's going to have its own niche use cases. So a couple of use cases which come to your mind is, of course, the disaster. That's very, very important information, especially in a vast country like India. The second could be education, right? For broadcasting education kind of, or distance education kind of use cases. So these are the 2 use cases which are extremely important.
And Vinod, you wanted to add on?
It's a very interesting topic, and it's something which everybody would love to have, a phone which is doing everything in every place. Interesting concept, but it has challenges. If you see today where we stand in D2D market, has primarily, you have something which is happening today, SOS and messaging, which iPhone 14 and is doing with Global Star as a partner, and and it's kind of a free service. Monetization is a big challenge. How do they monetize it? Then there's one more market which is talks about the unmodified market, which is like my standard smartphone talking to a satellite. I don't change anything on the phone, but it is the satellite companies which do something on the satellite and which enable them to communicate with the phone, and it's on currently on R15 and R16 and below. And this is the biggest market. If you say it's a 5 billion handsets who are talking about revenues of $18 billion in next 5 years, with current partnerships talking about around a billion phones being as a prospect. So we have companies like AST, Link, Starlink, who are basically making either more satellites or larger satellites to enable such kind of connectivities. But they're all of them are today limited to SOS messaging, and as we move, that's what it is today. Now, when we move to R17 kind of a chipset, where we have 3GBP handsets available, it will move to a little bit better side, where we'll see voice and some kind of limited data, but it will have its own challenges. If you ask me, how do you see it 5 years from now? I think in India perspective, definitely it's we have many regulatory challenges, and I don't see it as any starter in India for next 2 to 3 years unless we solve many other issues. And there is, and if you see from the 5 years from now, it's not even tens of satellites which AST or Link will launch, it is hundreds of them. Otherwise what will be a service will be like long wait and a short service. The satellite is moving, you wait for it when it comes, and then, so it needs a lot of investment. And the challenge is, how do you monetize it? What is it like? Give it free, have a revenue share with MNO, what kind of revenue share? So these are very open questions, and if you see 5 years from now in India, I don't see it as a starter, as a direct-to-device. But as a concept, I would really love it to succeed. Maybe on the 6G, when the 5G NTN is tweaking of 5G waveform. It's not something, a new waveform which was designed for satellite. It's tweaking the existing waveform. If we go for 6G, which is 2030 onwards, maybe the work has started. They create a different waveform which has capability to talk to a satellite in a different way, the way it accesses the resources on a satellite, the bandwidth, and provides speeds to a mobile and the link budgets, and there are many other challenges on that. So maybe that could be something which is interesting, but what I see on the 5G today, it will remain an interesting concept on the paper, but limited to SOS, limited voice, and limited to very isolated rural areas, and monetization and business case will have its own challenges.
So just wanted to add what Vinod has said. From the SATCOM perspective, as he rightly said, the faster the approvals. The reason being is, like a traditional geostationary satellite, whose life is 16 to 18 years, these satellites have got a 8 or 10 year of life. So if there is a delay in, let's say, regulatory approvals or landing rights or gateway approvals, so by the time the approvals come, half of the life of the satellite is gone. And then you're looking for a next wave of next constellation of satellites.
Noted. So regulatory and policy is a thing to watch out for, especially in India. So when we speak of the Indian context, I also think of pricing to be really sensitive and cost economics to be a key factor when thinking of applications. So I want to come back to the rural broadband application and try to understand if it's economically attractive considering telco-satellite integration, and how much time would it take to become affordable and scalable? Like, what is your view on it? So Vikram, your thoughts on that?
So, currently in India, from an affordability perspective, the data costs are pretty low, In fact, the other day when there was the discussion on Wi-Fi, right? Earlier, one more used to look for a Wi-Fi connection, right? Now, I get a bundled package, okay? The same thing now, will I be looking for a satellite connection? Right. As far as the user is concerned, I don't care where the signal is coming from, as long as I'm getting some service or some value delivered in my daily life, right? And now, let's take our minds to why are places not covered? Which, the popular, I want to really, the popular kind of, understanding or the communication seems to be, hey, the satellite guys are going to, cover the uncovered areas. Nobody is putting money in these constellations for that. I haven't grasped that. If you're covering an urban area, there's no reason why you would not want to make money there. How do you recover your investment? So this popular, thinking that, okay, the uncovered areas. So that is where the economics or the discussion between the terrestrial networks and the satellite tie-ups. So obviously, demand aggregation is one thing which would help. The other is, okay, tie-ups in, collaboration is very important, because if you collaborate and, as he said, develop the ecosystem, a higher and a more coordinated ecosystem all across, right? From the devices to the access to whether it's satellite or terrestrial or to the backhaul, all this entire ecosystem will drive affordability. And that is where one needs to put significant attention.
I would also like to add a very important point that we must also, I know that India is a huge country, there are a lot of challenges, but I must also compliment the efforts of ISRO, InSpace, and ANSIL, because they have realized the pressure, the kind of applications, the demand, and last year we saw a first private player, coming into India who will own a private ISRO orbital location, the Indian orbital slot. So ISRO has realized the importance of that, and in future also we'll see some more encouragement by ISRO and ANSIL and InSpace to encourage private operators. You see the space, the kind of space startup support Indian government is giving, to whether it's agriculture, whether it's IoTs, companies like Novaspace, companies like Azista, companies like, there are so many companies which are coming up. So I think, I know it's a big country, lot of challenges, but full compliments to ISRO and InSpace for realizing that and fully supporting the space policy and the new space policy as well. It's a fully reformed policy now. You see satellite operators and telco can get into a partnership. OneWeb, Bharti, Geo, SES. So you see, so the market is opening up. So I mean, hats off to these people. Yeah.
Yep. So at this point, I think I want to talk a little bit about the future outlook and strategic priorities as well. So when I think of it, 6G comes to mind. So what strategic shifts should stakeholders make today to remain competitive in the 6G 2030 world? So Manoj, do you want to kick off?
The good news is that the train to 6G station has already started. Although the 5G monetization narrative is very strong, but still. When you talk about 6G, one of the foundational pillars is terrestrial and NTN interworking. I think that's there in the definition. Right? And I talked about ubiquity. If you look at the ITU definition of 6G, ubiquity is, and that was something which was coming from India only. So ubiquity is going to be key. So let's start from the terminals. So from the terminals point of view, the support of NTN will be there throughout the terminals, all the CPEs, all the frequencies, all the technologies. I think that will need to be there. Only then the systems will seamlessly interwork. Then let's talk about the network. So there are several architectures which have been identified. So there is a transparent architecture which has been identified. Then there is a regenerative architecture which has been identified. So it gives you flexibility, it gives you a lot of options to have your network architecture of your choice. The third thing is things like location inbuilt, which means having less and less dependence on the GNSS kind of systems, and that gives you flexibility to serve the latency specific applications. So that will happen. Then it gives you flexibility to have movement across LEO, MEO, and GEO kind of system. So the technology will be advancing, you will be having steerable antennas, etc. And so I think these are the broad, and of course, artificial intelligence will be the foundational pillar of 6G. But going forward, I think there will be no two worlds. There will be one world, which will be the integrated terrestrial and the NTN world. The services are likely to be more seamless and more continuous. So I think that's the 6G vision in general.
Perfect. That's a good statement. There won't be two worlds. That'll be my closing remarks today. But Vikram, do you want to add on the 6G?
See, on the 6G part, as he mentioned, there's huge conversation about, the amount of money globally that has been invested in 5G and monetizing 5G. Right? So that from operator's point of view is a big, focus area. So the transition or the segue to 6G, as we, right now there is a ITO 5D meeting happening in Kobe, Japan, where the discussions are on what all should be the parameters of a 6G network. Of course, subsequently the parameters will be what levels, all that. But that discussion is on. So the learnings, at least that from India that we are saying, is 5G had too many variations in the network. You had non-standalone, standalone, network slicing, so the permutations, combinations in a 5G network, the choices actually made it complicated for telecom operators from a network deployment point of view, right? Now, one of the things in 6G particularly, it was there in 5G, but increasingly will be power consumption. Your ability to produce a gigabit of data, in the end you're producing data because what you're transmitting up and down or whichever network you call it. So it is the cost or the energy cost per hertz per bit is something which would require a lot of attention, because as you're aware, you mentioned about AI, or you see cryptocurrency or gaming or video. The amount of energy required to run all these services is something which will be right in the center of the focus for developing the 6G, network.
Noted. So, yeah.
You talked about the energy. So energy is again going to be a very, very important aspect of 6G. So if you see the energy consumption at the product level, I think a lot of advancement is happening in terms of the power consumption. Chips are becoming more efficient. But what is happening in parallel is the traffic is skyrocketing. Right? So today Indian consumer consumes something like 30 GB per user per month. The forecast is that it's going to double by 2030. Right? The second thing which is happening is the densification of the network. You have huge amount of base stations for this population, for this traffic increase which you are planting. So at the network level, the energy consumption is actually galloping. You may be looking at per GB level or whatever, and which is not good for sustainability reasons. So what 6G has done is that, hey, let's take a target. We'll halve the network level power consumption by 50%. That's the target which 6G is taking. And which is here, things like AI, which Vikram mentioned. So everything has to work in tandem. We are not going to look at the power consumption at the product level or at the node level, but we are going to look at the overall network level. And the target is to reduce the network-wide power consumption by half. So I think that's the paradigm shift.
So just to add from the satellite perspective, where 6G, and the satellite changes which you'll see in 2030 onwards, you'll see, we already seen LEO constellations which will be more and more coming, and so you'll have more capacity at a less delay. You'll have MEO satellites coming in. You'll have geo high throughput satellites, software defined with software defined capabilities, where technologies are changing on the ground to enable seamless integration with the high throughput satellites. So the capacities are increasing. There are billions of dollars of investments on the satellite launching and new satellite constellations coming up. And there will be as you know, we understand the demand is going to be high, and there will be areas where satellite will be part of the telco's overall strategy, and the satellite industry is geared up to meet the demand and with new constellations.
Since we spoke about satellite and telco, so one final question from my end, and then we can have maybe a couple of questions from the audience in interest of time. And this is for everyone. So looking ahead, how do you think the competitive dynamics between satellite and telco players will evolve? Will you see more collaboration or outright competition or even some bit of consolidation?
So I think telcos and satellite operators, are interdependent on each other. It's a convergence and not a competition. So so from Astrana's point of view, perspective, I think we build, operate, and launch dedicated Ka-band high throughput satellites, geostationary satellites, micro geo satellites, tailor-make specific for telco requirements, right? As I mentioned earlier, that we do a lot of beam reconfigurations, and I wanted to share with all of you that if you order a normal geostationary satellite today, the cost of the satellite is about $250 million. You need to make an upfront payment of $50-60 million once the satellite is start building. Astranis here, why I'm saying that, because it goes well with the telco, because telco will also do a lot of investments on the ground. So we have a very unique financial model whereby you pay a small fee upfront, let's say $7 to $10 million. We don't take any money after that until the satellite is built and launched, right? So we are looking at a window of 12 to 18 months, because a block of satellite, we are mandated to launch multiple blocks of satellites every 12 to 18 months, right? And once the satellite is launched and achieves the orbit, we then start the monthly equal installments up till the end of the satellite life to support telcos. And there are cases where people cannot afford to pay, because telcos would be doing a lot of investments on the ground, right? Also, we take the headache of designing, build, launch, and operate the satellite. We leave telco to manage the ground. We don't want them to also do a satellite management, right? So everything is on us when it comes to space, and we leave telcos because they are the best, to take care of the ground, the acquisitions, the ground infrastructure, the gateway. Yeah.
Manoj?
If you look at the future network services, I think the only option left is the collaboration, cooperation, and harmonization. So I think that's pretty obvious.
Okay. Short and sweet.
So in the near term, it will be collaboration, which is already happening. The mid-term would be more like, in the market, you need competition. Right. And competition, particularly, from telcos globally, that you're seeing is, okay, a 3 telco model per country. But that competition, along with the satellite part, with the partnership. And in the longer term, it will be, let's say, consolidation. So that's the way one sees it. As the market matures, then you consolidate. That's it.
I go with the panel. It's mainly collaboration which will continue to happen. And the only thing is there would be, as the satellite industry offers moves from GEO, MEO, and LEO, I think we'll have all the assets telco will have to have, and we'll have a multi-orbit kind of platforms with 5G and TN being part of the whole ecosystem, and that's what I think would be a collaborative approach. And towards the end, obviously, consolidation has to happen, and the telcos and the satellite operators will have to work on whether it's a multi-orbit, it is single orbit, it is geo orbit. That will depend on the various use cases.
Thank you. So probably we can take 2 questions from the audience. So if you could state your name, organization you represent, and who the question is directed to. So do we have a mic? Is there a mic? Sorry.
Hi, I'm Deepak Maheshwari. I just want to clarify one thing. Vinod did mention about the VSAT license. Now, VSAT license is basically for COG services, which does not allow connectivity to the public data networks in that sense. However, it's also important for us to remember, notwithstanding whatever is happening now for past few weeks or months or years, that since the launch of the ISP policy in India, since 6 November 1998, use of satellite is already permitted under that license itself for internet services. Thank you.
Hi, my name is Nitish. I'm from InSpace. I wanted to ask from industry point of view, what expectations do you have from InSpace to enable integration of telco-satellite networks?
See, the important part is co-developing the standards. The investments in co-developing the standards, investments in R&D, making that attractive. Because as this space would grow, so there's a lot of investments in developing the technology. Right? And of course, the support that whether it's in space or the government to provide, let's say, via economic incentive or via investments from the state, particularly in areas where it lacks a business case of economic viability.
Okay,
I think,
perfect.
just I'll add to what Vikram said. So Vikram said standards. So standards is all about consensus building, right? And I think that's something which can always be encouraged by the regulator. And so I mean, the needs can be local, but the standards eventually will be global. I think that's the theory which we should all believe.
In the standard space, we did make a mistake in the 5G journey. So just to be clear, standards are global. Very often under the umbrella of Atmanirbharta, should not fall into the trap of saying that there's an India standard. The global standard, participate in 3GPP, participate in ITU. The good news is we see a lot of enhanced Indian participation at the international standards building forums.
Okay, perfect. So thank you so much for your questions as well. I will just close the session by thanking the panelists, and it's clear that satellite and telco integration is not a buzzword. It's imperative now, and there are certain considerations for policy and technology that we need to look out for. And as Manoj said, these are not two worlds, it's one world. And going forward, it will start with collaboration and probably end up in consolidation. So thank you so much.
Thank you, Ms. Grace, and thank you, dear panelists. It was indeed a very interesting session. May I request Ms. Grace to felicitate our panelists with a memento? Mr. Vinod Kaul, and to Mr. Vikram Tiwathia, Mr. Manoj Gurnani, and to Mr. Vikram, sorry, my bad, Mr. Vishal. May I request Mr. Hegre to come on the stage to felicitate our moderator, Ms. Grace from SIA-INDIA. Please come. May I request all of you to just come in front for a group photo? You can go on the front? Yes, please, thank you. Thank you so much.